Question: is it possible to experience music without sound? Hold on to that. Hold on to your responses. It's a bit of an absurd sort of question. We think about music as coming to us through input through our ears. Well, what if we don't have access to input through our ears? Okay, and that's certainly the case for many individuals who are born deaf, hard of hearing, and for many of us who will lose our hearing over time. I've had many deaf individuals tell me that, look, I really don't care for music. It doesn't matter to me. I'm perfectly fine, thank you. But I've had many more tell me that I absolutely love music. I want more of it. I want to be able to create the music myself. Well, again, how is this possible if we don't have access to sound? There are other options. We have other sensory modalities. Is it possible that we can bring music to people through these other sensory modalities? And this has been the focus of the kind of work we've been doing over the last 10 years. So we've got these other senses. Let's consider them. Taste, smell. That again sounds absurd. How is it that we could bring music through those senses? We have actually experimented a little bit with those senses. Thankfully, those experiments are over. Vision. Dance is often set to music, and dance, of course, is extremely visual. So there's some possibilities there. What about touch? When I sing, I can feel my own voice. Okay, so again, it seems that there's some possibilities there. So perhaps by harnessing vision and touch together, we may be able to create the essence of music and provide that experience without that sound input. I trace my interest in this subject back to when I was about 19 years old. I had this fantastic summer job working at a large auditorium where we had a lot of great acts come through. One in particular that I was extremely excited about was B.B. King. I was looking forward to it all summer, did my best to get on the floor that night and to meet B.B. He entertained my naive questions about the blues. He even gave me this great pin that I carried around on my guitar case for years. Now, I don't tell you this to impress upon you what a great guy B.B. is. He's definitely a great guy. But rather to point up the contrast between his calm and rather dignified demeanor in person and his absolute theatrics on stage. Now, if you've seen B.B. King on stage, you know exactly what I mean. I'm talking about the furrowed brow, the shaking, and that arching back. Okay, so let's have a look just so that we're all clear in what I'm talking about. So I asked myself, were those theatrics really necessary? It turns out that the answer is yes. Together with my colleague Bill Thompson from Macquarie University in Sydney, we've been looking at aspects of music that can be conveyed by visual input. One of our early experiments on this subject actually involved concert footage from B.B. King. What we did is we selected clips where he was looking rather serene while playing a blues progression, other clips where he was looking downright tortured. What we did is to control the amount of musical dissonance, how harsh the sound appears, over all of our clips, but manipulate basically by clip selection whether he seemed serene or whether he seemed tortured. And as you might expect, people's judgments of dissonance were incredibly influenced by what it was that they were seeing. So it really does seem that what you see matters. I think the most interesting work along this visual line that we've done is to look at what can be seen visually in terms of singing. It turns out that you can actually see the size of an interval. So what I mean by a melodic interval is the distance between two pitches. You can actually see that a larger interval looks different than a smaller interval. So I'll attempt to demonstrate. Do, re, mi, do, mi. Relatively small interval, not a lot of movement. Do, re, mi, fa, so, do, so. For me, when I sing the do, so, I can't help but move a little more, my eyebrows raise, my mouth opens more than it did when I sang the do, mi. Do, re, mi, fa, sol, la, ti, do, do, do. When I attempt to sing that, I have a lot of movement. And again, my eyebrows are raising, my mouth is opening. So what we found using motion tracking is that this is quite lawful. Across singers, we have this relationship between these visual characteristics and the intervals that people sing. Now, if you start to string together these intervals, you can actually start to see melodic contour. So if I were to sing do, mi, do, so, do, do. I'll now repeat this silently. I find it's technically flawless that way, and I sort of prefer to do it that way. I think you get my meaning. Well, moving on, what about tactile aspects of music? What is it that we can feel and make sense of? So there's a very old history here when it comes to tactile music. Some of you may be familiar with the famous story of Beethoven sawing the legs off of his piano. Why would he do something like this? Well, he did it because, of course, he grew progressively deaf with age, and he was passionate about music. So he brought the piano down to the floor, and he lay his body down on the floor along with it, so that he could actually feel the music through the floorboards and make sense of the experiments he was involved with in developing his compositions. Shoot ahead a couple of hundred years, and we can find deaf kids in a rave this coming Saturday night, any Saturday night really, where the bass is pumped up as loud as possible. Okay, and what is it that they're doing? They are feeling that music through their bodies. They're getting it through the floorboards, much the same way that Beethoven did. Okay, so there's a long history here, and we know that it's possible to get music through vibration. When we started to experiment with the possibilities of, what are the limits of music perception through vibration, we ran up against a basic problem, and the problem is known as perceptual masking. It presents itself in all of the modalities. It definitely presents itself when you're dealing with vibration. Basically what I'm saying is that if you put a low frequency vibration and a high frequency vibration together on the same part of the body, the low frequency vibration wins. It's as if the high frequency vibration is not there at all. To solve this problem, we started to develop the first prototypes of what's come to be known as the Emotichair. What we've done is basically to separate out the different frequency ranges and present them to different parts of the body so that you can feel the low frequency and the high frequency at the same time. You don't have this problem of masking. So this is a bit of a mock-up, a model of how this works. What you're looking at on the left side of the screen is a schematic representation of your inner ear. On the right side of the screen, you see how the Emotichair is laid out. This is one conceptualization. We've experimented with others. The important thing here is that the inner ear, or the cochlea, has a frequency to place mapping. So every part of your cochlea codes for a unique frequency range. We've attempted to do the same thing with the Emotichair. We are allocating a specific part on your back for a specific frequency range. And when we do this, again, we get this really rich experience of the emotional and structural characteristics of music. What have we shown in the lab? We've seen that without sound, people are able to discriminate pitches that are as close together as two semitones. So that's the pitch distance between two white keys on the keyboard. They can feel the difference between two timbres, so for example, a piano and a cello. They can feel the difference between two human voices. I find that absolutely remarkable. More importantly, perhaps, they can feel the emotion in the music. So without sound, you'd be able to feel the difference between a happy tune and a sad tune. So how in the world is this possible? How is it that people are making sense of music without any sound input? In order to understand this, sorry, I've shot ahead there. In order to understand this, we have to consider very briefly the word emotion. Emotion, you can trace the word origin of emotion back to its Latin roots and the word emovere from medieval Latin. And emovere essentially means to move. Many of you will have thought about the movement that's implied by music. There's a great deal of movement implied by music. Well, motion, movement, and emotion are all intricately linked. When I'm trying to understand the emotion of someone that I'm talking with, or I'm in their presence, I'm trying to understand the way that they're moving. So if someone is moving very slowly and they look very heavy, then I get a sense of melancholy. That looks very different from a sense of anger, rapid movements. So motion is at the key of emotion. Music also implies motion. The motion can be implied through pitch movement, through tempo, through the transitions between the pitches. Making sense of all this implied movement probably requires the mere neuron system. The mere neuron system is a collection of neurons in frontal and parietal areas that codes for the actions of ourselves and the actions of others. It's as if these neurons were holding up a mirror to the actions of others to make sense of the world around us. So this is our working model for basically how we're experiencing emotion in music. Sound comes in normally through the ear, makes its way into the primary auditory cortex. That feeds forward into this mere neuron system where the motion implied the music is being simulated. And that in turn activates primitive emotion networks, so the limbic system. Okay, and that's how we're feeling the emotion in music. What happens if we drop away the ear? Okay, we don't have access to that sound input. Well, let's take input from the visual system. We'll feed it into the visual cortex. That will in turn get fed into an area called the superior temporal sulcus. It's an area of the visual system that codes specifically for movement. That in turn projects to the mere neuron system, which again will activate the limbic system. The really amazing thing about the new research on the mere neuron system is that it takes input from sound, vision, and touch. So without the sound, you can capture the sense of motion and in turn emotion. Over the last couple of years, we've put on a number of concerts. There have been 25 concerts to date, and we have been experimenting with bringing this technology to the public. We've also been experimenting with creating music where sound is not the primary modality, but rather it's relegated to the background, and the visual modality and the vibrotactile modality are up front. I'm going to play you very quickly a piece composed by a friend of mine, composer Paul Swoger-Ruston, and you'll get a sense of what music can sound like when vibration is the primary mode of composition. Okay, I think you get the idea. So what we're working on now is thinking about whether or not an entirely new art form is possible, where we reallocate the sensory priorities so that vision and touch are the primary modalities that we're trying to use to communicate emotion through music. We've brought the deaf community on board, or rather we're working together and we're working collaboratively. They've been involved in the empirical work, the scientific work, as well as the artistic creative side. In our latest realization of this, we brought together deaf artists and hearing artists working together to develop a composition that was entirely visual and vibratory. So in closing, I want to come back to the original question. Is it possible to experience music without sound? For me, the answer is unequivocally yes. It is entirely possible, and in so doing, we may be opening up a new innovative art form that can be embraced by hearing and deaf individuals alike. Thank you.